Hello everyone, and welcome to the section or part 2 of the lecture, which is we will talk about the basic ray diagram. The basic ray diagram we will talk about how we can make the imaging using the lenses. This is the introduction of the eye, so we will understand how to make the image, and then you will understand the cases of our eye. We are using the convex lens. This is the convex lens. And this is the convex. Why you are using the convex lens? Because our eye is the convex, so it will be beneficial to understand how the convex lens work. First of all, you should understand the ray diagram, this is the ray diagram. It starts with the principal axis, this is the principal axis, the line passing through the center of curvature of the lens. This is the principal axis. Principal focus is the point here that where the ray parallel to the principal axis converging. Okay, so principal focus is the focal point that is just like coming here. If the light coming from the infinity, it will be focused on the focal point. Okay, if the light coming from infinity, so there is no from far away, it will be focused on where? On the focal point. All right. If it's not focal on the focal point, it will be passing through the focal point. So this point is important for us. All right. And the focal length, what is the focal? This is the focal point, which is sometimes we name it the principal focus. The focal length is just the distance between the focal point and the lens, and the middle of the lens. So this is the middle of the lens. This is the focal point. This is the name is focal length. The optical center is just like this is the optical center, C, or optical center. This point is the imaginary point inside the lens through which light ray is able to travel without being deviated. So when the light passing through the middle of the lens, it will be passing through any deviation. So there is no reflection happen. All right. Okay. We will see it. We understand when we have the cases. We have different positions of the object. We will put object and we will see how this object will be can be make the images. We have object position between F and the lens. Of course, here the focal point on that side, the focal point can be on that side as well. Okay, so the distance, the same distance here, it should be the same distance here, and then we can point. If I put it for you, so for example, here is the F, the focal point. Okay, and the distance here is the focal length as well. Let's say this is your F1 and this one will be F2. We will name it like this, for example. All right, now how can these things happen? First of all, just like we have object, will be position it, we will put it between F and the lens. So this is the F, as we said, F can be here and here. This is F. We will put, this is the lens, this is the front of the lens, this is the back of the lens. So we will put object between F and the lens. Between F and the lens. We'll put object at F at this point. We'll put object between F and 2F. What is the 2F? 2F is the double of F. For example, this is the distance is 10 centimeter F. So this is another 10 here. It will be 2F. Another 10 it will be 3F and so on. And then we'll put object at 2F of the lens. Okay, so we have 4 positions. Let's start with the first one. When the object, we will put the object at 2F. This is the object at 2F. Okay, what should we will do? We will have 2 lines. Okay, the first line will be go from the object, it will be go to the middle of the lens. Okay, and then it will be deviated or it will be reflected. Once it will be reflected, it will be passing through the focal point here, as we said. The light will be passing through the focal point. Now the second line, it will be starting from the same from the object, and then it will be passing through the middle of the lens till without any reflection. Okay, when they are meeting together here, this is the point. Okay, how can I read the image here? Because the image will be in this is the object on the left side, because the image on the right side, on this side, okay, that means is a real image. Okay, so the object here, this is the black one is object, this one is the image, it will be a real image. It will be inverted because the object is up faces up, the image is faces what? Is faces down. The same size, you will measure the length of that object, and you'll measure the length of that image. If they are the same length, they will be the same size. All right. Now going to the second one, when the object between f and 2f, what will happen? So the first procedure, you will do the first line, go to the middle of the lens, and then reflect it. When it's reflected, it will be passing it through f. Okay, the second line will be go in the middle of the lens and will be passing without any deviation. When they are meeting together, we will make what? The image. Now, the image, because the object on that side, the image on that side, what you expect, the image will be real. Okay, it will be inverted because this one is facing up, this one is facing what? Down. It will be magnified, meaning that the object is smaller than the image. So the image, see, the image is bigger than the object, which is, we name it projector. That means it will be magnified. This is the case. When we have the object on the F, now we put the object on the F, we will make the line in the middle and then passing it through F2 as the procedure happen always. And then passing it through the F, the middle of the lens, the optical center is passing. So see, there is no meeting or there is no intersect between the light. When there is no intersect on the light, that means there is no image is formed. Okay, so the image will be what? Will be not formed. All right. The last case we have it here is just like between f and 2f. When between f and the lens. So first of all, you will put the line. You will start with you will put the object. You will get the line and then start to the middle of the lens and will be passing through f2. And then from the f2, from the same object passing through f, see, they are not meeting. But when you are taking the extension of the light, the extension, you will see they are meeting on that point. Okay, that means this image. Now, what is the properties of this image? Because we said before, for example, here we said here, because the object on the opposite, not opposite, it is the object on the left side, the image on the right side, on this side, or here, that means it will be a real image. However, in terms of this case, because both of them, they are the same side, that means it will be inverted image. It is bigger or the smaller, it will be bigger, so that means it will be magnified image. So the image is magnified, it's bigger than the object, and it will be virtual. Okay. Okay, I will go to this one and then return back to the others. So we have, to summarize all of these things, when the image will be at 2f, this is the case we took it, you can find it. The position of the image will be at 2f as well. They will have the same size. The image properties will be real and inverted. Between f and 2f, the image will be beyond 2f. It will be enlarged and it will be real and inverted. At focus point f1, the image will be at infinity, the position at infinity, and the image will be so infinity. So don't focus on that. So at infinity, there is no image will be formed. Between the focus f1 and the optical center, on the same side of the lens of the object, so it will be enlarged, virtual, and erect. Okay, but here just let me focus on the f1. When you said it's at infinity, that means maybe there is image at infinity. Once the image will be created at the infinity, there is image, it will be real and inverted. Once it will be created at infinity, if not created, you will say there is no image. So what I want from you now, from next week, you will bring it with you. Draw as a homework, draw this infinity. This is homework. And this one as well is homework for you. So you should bring it next week, okay? Or like a Sunday and Monday as well. Okay, right. Now, what do we have? Okay, what is the power of the lens? The power of the lens is just like is the 1 over the focal length. If you remember, I said, what is the focal length? For example, where is the focal length here? The focal length is, or here, just we have it here. The focal length is the distance between the focal point and the middle of the lens. So this is the focal length. P, which is the power, is 1 over this F, 1 over the opposite of this F. All right? This is the what we said about the power. Power is the 1 over focal length. The focal length is measured by meters. 1 over meter, we name it as diameters. This is the unit of the power in terms of the power of the lens. Okay. And the power have 3 cases. Sometimes the power will be positive. When the power will be positive? When you are using the convex lens. Okay. This one is for convex lens. Okay. The diverging lens, this one for the concave lens. Okay. This one, no lens. Okay. So so if you have a concave lens, you will see a minus. When you have a convex lens, you will see the we'll say it is the negative one concave and the positive one will be the convex one. All right. Now, what is else we have? We have something we name as image distances or object distance. The object distance is the distance between the object and the middle of the lens. We name it U. The image distance is the image between the image and the middle of the lens. As we said before, F, it will be the distance between F and the. So what is the formula can control this one? 1 over F equal 1 over U plus 1 over V. Okay, U is the distance, object distance, and V is the image distance. We have another formula we name is M, magnification, and M is equal to V over what? V over U. Okay, when using this equation, a sign convention must be beyond. So the sign important here, listen to me guys carefully. The distances from the lens to the real object and real images are positive. So here, when the object is real, when the image is real, and always you are, in this case, always you are using the object is real. When the object is real and the image is real, the distances here will be positive. Okay. When the object is imaginary, and this is not our case, we will not take object is imaginary. So when the image is imaginary, when the image will be imaginary, what's mean by imaginary? It means will be virtual image, like this image here. Now, this is the image here, is the virtual image. So the distance between the image and the middle of the lens will be what? Will be negative. Okay. And it just like this is how it works. So the image will be negative when it will be when it will be virtual image, and the image will be positive when we have a real image. The object distance will be positive when you are talking about the real object, and this is our case only, we don't have another case. In terms of the focal length, what will happen? When you have it's not depend on the virtual image or real image, depend on the lens itself. So the focal length will be depend on the lens. When the lens is real, when the lens is convex lens, it means you will have what we will say it, we will have a positive focal length. When you have a negative, when you have a negative focal length, that means we are talking about the concave lens. So if I am writing it for you, you will see this is what I am saying. First of all, V equal positive, U is positive as well. U is positive as well. When you have a real image and object. Okay. Again, V is negative. We have just this case. We don't have U is negative. V is that means you have a virtual image. Okay. What about the focal length? I will write here. The focal length when F is F and P, the power, the same. It will be negative. That means I am talking about the concave lens. When they are positive, F equal P the same. it will be positive. That means you are talking about convex lens. Okay. So anytime the convex lens is coming to you, you will say the focal length or the power will be positive, and if they are concave lens coming to you, you will say it will be what? It will be negative. And this is the end of section 2. Thank you very much.